So this video is going to walk us through factoring. Factoring is a huge part of algebraic understanding, especially as you move into Algebra 2. So this is going to be a super important lesson for you guys to work through. To start off with factoring, we're going to talk about really basically what is a factor. So if you think back to 6th grade when you learned about GCF, or greatest common factor, it's the parts of a multiplication problem. So let's say that we have 15. The factors of 15 could be 3 and 5, because 3 times 5 equals 15. So 3 and 5 would be considered factors of 15. Now, if we didn't have just 15, but let's say that we had 15x. Now, 15x could have factors of 15 and 1x. So 15 times 1x would equal 15x. It could also have factors of maybe 3x and 5, which would also be 15x. Maybe it could even have 3 and 5x, which would still be 15x, or even 15x and 1, which would still be 15x. On the same side of those, you could also have negative 3x and negative 5, because a negative times a negative would still be a positive 15x. So there are lots of different factors that you can think of when we're talking about what a factor is. Now, what we're going to be doing is looking for the greatest common factor between different terms in a function. So, for our function of 6x squared plus 8x, we're going to kind of break this down. 6x squared could be written as 2 times 3 times x times x. It's kind of the prime factorization of 6x squared. And then 8x could be 2 times 2 times 2 times x, or 2 times 4 times x. But prime factorization would be 2 times 2 times 2. Now, if we're looking at these, what do they have in common? So here, they both include a 2. They also both include an x. So we would say that they have a 2x in common. Didn't mean to write in highlighter. Okay, so they have 2x in common. What do they not have in common would be what would go here in parentheses. So you want to kind of think about, if I were to distribute 2x back into this parentheses, what would need to be there so that I would still have 6x squared plus 8x? So 2x times the remaining part here of 3x, 2x times 3x would be 6x squared. Then 2x times 4 would give you 8x. So 2x times 3x and then 2x times 4 would get you back to 8x. So we would say the factored form of this would be the 2x times 3x plus 4. This is the factored form of 6x squared plus 8x, because it's a binomial and a monomial that multiply back to get the original format. So on this problem, what we want to do is now find the greatest common factor between 3 terms. So if you look at 8, 4, and 12, you might already realize that the greatest common factor between 8, 4, and 12 is going to be a 4. So I'm going to rewrite all these as factors of 4. So this would be 2 times 4 times x times x times x. If you wanted to go to prime factorization, it'd be 2 times 2 times 2. Plus 4 times x would be 4x squared. Minus 3 times 4 times x. So if we're looking at what they have in common, then their greatest common factor here would be 4x, 4x, and 4x. So we're going to factor out 4x. So I'll bring 4x out in front. That will be the monomial. And then the other term, the other factor will be what's remaining from each of those terms. So 4x times what would have given us 8x cubed? Well, that would be the 2 and the x squared. So 2x squared. 4x times 2x squared would be 8x cubed. For the middle term, 4x times just x, so positive x, would give us 4x squared. And 4x times negative 3 would give us negative 12x. So we're really looking at what's left on each of those original terms. So now we have this monomial and this trinomial that are the factors of 8x cubed plus 4x squared minus 12x. So I'd like you to see if you could find the greatest common factor between these two terms on your own. And then when you're ready, go ahead and see how you did. So between 5x cubed and 20x squared, we could write this as 5 times x times x times x plus 4 times 5 times x. So that would give us in common a 5 and 2 x's. So I would write the factored form as 5x squared, that's their greatest common factor, times x plus 4. So that would be the factored form of this particular binomial. X. Again, I'd like you to try this one on your own, and then we will check it. So the greatest common factor between 6x cubed minus 9x squared plus 15x. So between 6, 9, and 15, the greatest common factor should be 3. So we have 2 times 3 times x times x times x minus 3 times 3 times x plus 3 times 5 times x. So then if I'm looking at greatest common factors, they each have a 3 in common, and they also each have at least one x in common. So I could write this factored form. The greatest common factor would be 3x. So I'll go ahead and write 3x, and then the other factor of each term will go inside this parenthesis. So 3x times 2x squared, that would be what's left over from the first term. For the middle term, we have a negative 3x, and for the last term, we have a positive 5. Now this one's going to be a little different. So this is going to be factoring by grouping. What we want to do is we want to come up with the two binomials that were the original factors to create this quadratic. So if you think back to when we learned how to multiply binomials, we used the box method mostly. So when we did the box method, if you remember, this top left box was always that squared term, that ax squared. And the bottom right box was the c value, in this case negative 2. Now we didn't know at that time that it was called ax squared and c, but now that we've talked more about quadratics, we should realize that. What we kind of touched on was that these two boxes should combine together, so they should add together to create that middle term. So they should match this positive 9x. What we really didn't talk about at all was that this diagonal here should have the same product as that yellow diagonal. So if we know that this red diagonal is negative 10x squared as a product, then that means that we also know that this diagonal is also negative 10x squared. Now that makes things much more interesting because we can come up with factors of negative 10x squared. And we know they both need to be an x because if you remember, both of these boxes should have an x in them so they can be combined. They have to be like terms. So I'm going to kind of list out some factors of negative 10x. Now, since it's negative, one has to be negative and one has to be positive. So let's just start with negative 10x and positive 1x. So So that would be negative 10x squared if I multiplied them back together. I could also invert those signs, so I could have positive 10x and negative 1x, which would still be 10x squared. I could have negative 5x and positive 2x, or I could have the exact same factors as the red diagonal, which would be to have a positive 5 and a negative 2. So those are really the only factors of negative 10x squared. I need to know which of those factors would combine if they were in those two boxes to make 9x. So if I think about them as being combined, this would then become negative 10x plus 1x, which is negative 9x. Now, I don't need negative 9x. I need positive 9x, so that's not going to work. So I'll just go ahead and scratch that one off. It's not it. So on this next row, I would have 10x plus negative 1x, which would be 9x. That should be what we're looking for, but I could quickly verify if negative 5x plus 2x is going to work. That's negative 3x. So no, that's not going to create 9x for us. Or 5x minus 2x, which is positive 3x. So that one also does not work. So the two boxes here should be positive 10x and negative 1x. Now, it really doesn't matter where you put them as long as one is in each box. Now what we want to do is more like what we did on the previous slides. We want to find the greatest common factor, but this time we're finding the greatest common factor of each row. So for this first row, let's see here. This first row here, what's the greatest common factor between 5x squared and 10x? Well, they both include an x, so I know there's going to be an x here. And then between 5 and 10, the greatest common factor is 5. So that would make that row 5x. For the second row, they're both negative, so this could be a negative. And that's really all they have in common. So we'll have to say a 1 because they don't have any other numbers in common. Now you could do the exact same thing on the columns, see what they have in common. But what I like to do here is I like to figure out, well, what did they multiply by to make those boxes? So 5x times what would have given us 5x squared? This is kind of like when we divided. So 5x times x would have given us 5x squared. 5x times 2 would have given us 10x. So that's going to be x plus 2. And then verify, does that work for the bottom? Negative 1 times x, is it negative 1x? Yes. Is negative 1 times 2 going to give us negative 2? Yes. So now we know that the two binomials were 5x minus 1 and x plus 2. So this would be the factored form by creating two binomials. I know that can seem really overwhelming, so we're going to do several of these examples, but this would be your final factored form. And where we're going to head with this in a couple of weeks is once we have it factored, then we could find the solution if we know what y is. So it becomes really interesting, but you definitely want to know how to factor. Okay, so this one, again, we're going to come up with two binomials. So I'm going to go ahead and create my box. And I know that the top left would be the ax squared. In this case, it's just x squared. And the bottom right would be c, which in this case is positive 30. Now I know that this diagonal has a product of 30x squared, which means that this diagonal should also have a product of 30x squared. And I also, looking at my terms here, know that this diagonal should combine to make 11x for us. Now, since the middle term is positive and it's 30x squared, I'm not even going to worry about the negative factors here. I'm only going to focus on two positives that create 30x squared for us. Because it must be positive if we're going to end up adding them and getting a positive. So 30x squared, well, that could be 1x and 30x. That would make 30x squared. It could be 2x and 15x. It could be 3 and 10x, 3x and 10x. Could be 5x and 6x, and I believe those are all the factors of 30x squared that are positive. Each of those could be negative, but that won't combine to make a positive, and we add. So what we want to do here is we want to add the terms together and see, are they going to combine to make that middle for us? So if we had 1x plus 30x, that would be 31x. So no, that does not make 11x. 2x plus 15x equals 17x. No, does not make 11x. 3x plus 10x equals 13x. Still not 11x, which is that middle term. 5x plus 6x does equal 11x. So these are the two factors that would have created 11x for us. So we want to put those in this box. So we're going to put 5x and 6x. And then just like we did before, sorry, we're going to find the greatest common factor for each row. So looking at x squared and 5x, the greatest common factor between those would be x. Between 6x and 30, the greatest common factor would be a 6. I could do the same thing on the column. What's the greatest common factor between x squared and 6x? Well, that would be x. Or I could think x times what is x squared? Well, x times x is x squared. X times what is 5x? Well, that would be positive 5. 5 is also the greatest common factor between 5x and 30. And 5 times 6 does make 30. So now I can say that the original factored form, the two binomials that created this trinomial, would have been x plus 5 times x plus 6. So that would be our factored form. Now, when we look at this one, if you're really paying attention here, you'll see that these are pretty large numbers. But what I see is that 20, 40, and 25 have a greatest common factor between those three terms. So what I want to do is go ahead and factor out what they have as a greatest common factor. That will make my number smaller. Could I use 20x squared and 25? Yes, I could. But that would be a very large number to have to factor out. So what I want to say is, well, they're all divisible by 5. So if I go ahead and factor out a 5, then I could rewrite this as 4x squared minus 8x minus 5. And that seems like much more reasonable numbers for me to have to deal with. I didn't have to worry about that on the other two. The numbers were already kind of small, and they really didn't have a common factor anyways. But when the numbers are larger, definitely want to check for a common factor. It'll just make your life easier. So now I'm going to go ahead. I'm not going to worry about the 5. I'm just going to worry about the 4x squared minus 8x minus 5. I know that 5 will just have to be at the beginning of my answer. So I'm going to place 4x squared and negative 5. So when I'm looking at this diagonal here, I know that it has to match this diagonal as a product. So the products have to match. And when I'm looking, I can see that this yellow diagonal is negative 20x squared, which means I know that this diagonal should also have a product of negative 20x squared, but together it should combine to make negative 8x. Now, there's quite a few factors of negative 20x squared. So to kind of help me limit how many I have to try, I know that it has to be negative when I combine them. That tells me that the larger factor should be negative and the smaller factor should be positive. Because if the larger factor is positive, then when I combine it, it will still be positive. So 20x squared could be 20x and 1x. I'm going to say that the 20 would be the negative. That way it would be a negative when I add them. And I can go ahead and do that. So negative 20x plus 1x is negative 19x. That's not going to work for us. We need negative 8. So those aren't the factors. Then I'm going to try negative 10x times 2x. Well, negative 10x plus 2x does equal negative 8x. So there we go. I don't even have to check any others. I could, but if I find one that works, might as well stop. So this one would be negative 10x and positive 2x. What we want to do next is figure out what the greatest common factor on each row is. So between 4x squared and 2x, the greatest common factor is 2 and x. And between negative 10x and negative 5, the greatest common factor would be negative 5. On the column, the greatest common factor between 4x squared and negative 10x would be 2x. Or I could think again, what would be multiplied by 2x to make 4x squared, and that would be another 2x. Here on 2x and negative 5, the only thing they have in common is 1, and 2x times 1 would have given us 2x. Negative 5 times 1 would have given us negative 5. So I don't really have space up here. I'm going to write it down here. So y equals, remember, don't forget about this 5 that we factored out. So I'm going to say 5 times 2x minus 5 times 2x plus 1. And that would be the factored form. If you did not factor out the 5, then you would want to distribute the 5 to either the 2x minus 5 or the 2x plus 1. You wouldn't distribute it to both because they're already multiplied together. So if you distribute it to one, it will go ahead and get multiplied to the other when you work it out. So basically, if you did distribute the 5, you would either have 10x minus 25 times 2x plus 1, or 2x minus 5 times 10x plus 5. It would be one of those two answers. Okay, you've seen quite a few of these now. I think that it's time for you to try some on your own. So go ahead and try this one and then check. So there's nothing in common between 4x squared and negative 15. So no common factors to pull out. The numbers are not massively huge. So 4x squared and negative 15, that tells me that that one is negative 60x squared, which means this other diagonal should also be negative 60x squared. And it should add together to make 4. That means my larger factor should be positive. So from negative 60x squared, I know the factors could be negative 1x and 60x, but that's going to be way too big because that's 59x when they combine. It could be negative 2x and 30x. Still seems too large because it's 28x when you combine them. Negative 4x and 15x would be 11x. We're getting there. I skipped one. Let's see. Negative 3x and 20x would be 17x, too large. Negative 5x and 12x would be 7x when it's combined. We're getting much closer. Negative 6x and 10x would be 4x. There we go. There's the one I need. So negative 6x, 10x. So the greatest common factor on the first row is going to be a 2x. By the way, I only pull out a negative if they're both negative. If one's negative and one's positive, I'll just pull out a positive factor. And then the greatest common factor between 10x and negative 15 would be a positive 5. Same thing on the columns, 4x squared and 10x. Greatest common factor is going to be 2x. And between negative 6x and negative 15 would be negative 3. Or if you're just forcing it to work, that would be the same thing. So this one should be y equals 2x plus 5 and 2x minus 3. Okay, you're going to try this one on your own as well and then check it. So when I'm looking at this one, if I have to multiply 12 times 14, that's going to be a fairly large number. So is there anything I could pull out, factor out, before I go ahead and figure out what they should multiply together? So they all are divisible by 2. So if I factor out a 2, it would make it 6x squared plus 11x minus 7. And then if I have to multiply 6x squared times negative 7, seems much more reasonable than multiplying 12 times negative 14. So over here with my box, I will do 6x squared and negative 7. So that's a negative 42x squared, which means this one should be negative 42x squared on this diagonal. So what are the factors of negative 42x squared that will combine together as like terms to create a positive 11x? That means that the larger factor should be positive so that combining becomes a positive. So let me think of some factors of negative 42x squared. We could have 42x and negative 1x. That's a combination of 41x, so too large. Let's see, we could do 2. Let's do 2. So 21x and negative 2x would make 19x. That's too large. Negative 3x and 14, so 14x and negative 3x would make 11x, and that's what we're looking for, 11x. So this will be filled in with 14x and negative 3x. So if we're looking for the greatest common factor on each row, between 6x squared and 14x would be 2x. And between negative 3x and negative 7 would be just negative 1. That's all they have in common. On the column, between 6x squared and negative 3x would be 3x, or 2x times 3x would make 6x squared. And then between 14 and negative 7 would be 7. So our factored form, not forgetting the 2 that we factored out at the beginning, would be 2 times 2x minus 1 and 3x plus 7. Or if you did not factor out the 2, then you probably had a lot more difficult time because those numbers were large. But you would have either had 4x minus 2 times 3x plus 7, or you would have had 2x minus 1 times 6x plus 14. So those would be equivalent answers too if you distribute the 2 to one of the 2 factors. All right, this will be our last example. You'll try it again on your own and then check it. This one should be much easier than the last 2. And so I'm going to go ahead and set up my box. These numbers are very small. We have x squared and positive 12. So I only need to get the factors of 12x squared. That means that both diagonals will match if they're both factors of 12x squared. So for 12x squared, ooh, this one's different. The middle term is negative, which means that they'll have to be 2 negative factors. So we could have negative 12x and negative 1x, which would make negative 13x. That's the only way to get a negative if you have a positive factor. If the product is positive, the only way to get a negative when you combine is for both to be negative. So then we could have negative 6x and negative 2x. That's negative 8x, and there it is right there. So we'll have negative 6x, negative 2x. The greatest common factor between that first row of x and 6x squared would be just x. And between negative 2x and 12 would be, I want to say positive 2, but I have to keep in mind that both of my factors were negative, so I'm actually going to have to make this a negative 2. Otherwise, because on the column here, on this column, they're both positive and negative as well. So it's going to end up being 2 negative binomials. So x minus 2. And then in the column, the greatest common factor is x. And between negative 6x and negative 12, the greatest common factor is going to be negative 6. I don't typically like to do that. And the only time you really have to do a negative greatest common factor is when you do have this situation where your C value is positive, but your B value is negative. So our factored form here should be x minus 6 and x minus 2. Okay, so that's how to factor a quadratic function into its binomial groups, and also just how to find the greatest common factor between terms, which you do have to do when you're factoring quadratics.